Okay, in this tutorial, now that we've gone through each type of graph, I'm going to show you specifically, this is still in section 2.2, how to draw the graphs when you combine the A and B coefficients together. Now, the one thing you have to do is recall the periods and the period formula for cosine and sine are 0 to 2 pi. Radians are 0 to 360, both negative and positive if you do a negative period and positive period. And the one difference is that you have to remember that the tan graph only has a period of pi, so it changes a little bit different. So whenever drawing these graphs, the first thing you always do is draw out your grid. Let me just center that a little better there. Draw out your grid such that you have your grid with your 4 points, because we want to do a positive and a negative period. So what you do is you draw out your plane, your x and y Cartesian plane here, or your grid if you like, and you put in your 1, 2, 3, 4 evenly spaced in the positive side and your 4 evenly spaced on the negative side. That's the first thing you always do. The next thing you do is you decide, you look at the A value and you decide if it's negative, then you have to flip the maximums and minimums around. If it's not negative, then you just decide, do I have to go where my maximum is? It twice as much, half as much, and so forth like that. So put a maximum point. It's going to be 2 maximum and 2 minimum on this one. That's our max and min according to that. So now, after you've done those, set up your grid. You now know that it's cos graph, so it's going to have the cos shape. So you can go ahead and put in the cos shape if you'd like. Okay, so the cos shape is the W. And remember that you have to go down to the -2 and up to the +2. So you can put those in now, or you could do it in the next step as well, but I'm going to do it now. Okay, so then we have our cos shape. So now all we have to do, this will give us a negative and a positive period, which is traditionally what the question is. Draw one positive and one negative period of each graph. Okay, so there we have our, of course we should label these y and x. Okay, now we have to figure out what is here and what is here and what is here and what is here and what's in between. So now we have to know what we do is we know that the cos period, we have to calculate the period using the formula for period. And I'm going to do it here on the bottom. So we have to calculate it. We say that it's between 0 and 2 pi. Or if you like 360, if you're doing degrees, you could have that as 360. So now replace this theta with whatever x is there in this case. So this would be x over 2. So we have to multiply everything by 2. So it becomes 4 pi. So this becomes 4 pi here, and this is still 0 here. So what's halfway between 4 pi and 0? Well, that's 2 pi. Remember what I said last time? You could take this one plus this one and divide by 2 to get the middle. And then to get the middle of this one, you take this one plus this one and divide by 2 to get this one. It's just 3 pi. And this one plus this one divided by 2 is pi. And you would get the same thing here, except negative values in this case. Now later on, when we're working with the next set, you can get situations where the graph shifts horizontally as well, and we'll be looking at that in the next tutorial. So that's how you would draw that graph with those. I have enough time on the camera to flip over and do one more graph. Well, let's say we have a tan graph here. Obviously with tan graphs, you have to set up your graph a little bit differently. So set your graph up. Okay, now we want one positive and one negative period of this. So put a 0 there, but we still need our 4 irregular marks. Well, actually, we probably only won't need as many for this one because with this one, we're going to do more periods. But we know the regular tan graph has an asymptote here. And an asymptote here. And we know it also has an asymptote way out here. And here. So we know that because there's a 3 in front of it, that is going to give it the effect of straightening the tan graph out. So we're going to have, instead of if we say this is the 1 point, and this is the 2 point, and the 3 point, and this is -1, -2, and -3, let's say. So it's going to be straighter than the regular tan graph. So it's going to be a bit more straighter like that. But we know that from the A value. But what is the actual points that we put on here? Well, we know that the period of a tan graph is only from 0 to pi. Okay, meaning that this would regularly one here, this would be the pi that we'd hear, and then it repeats itself. Okay, so we're only looking at the inside here once. This one here, and this one here. So in order to draw a period, we probably don't even need these outside ones here. So we can, because it's only a pi period, we can ignore, if the question only asks for 1 period, we can ignore, 1 pi period, it would repeat itself there and repeat itself there. So we can ignore all this part here of our regular type graph. Okay? So it's going to shorten up our question a little bit. Okay, so we're only looking at this part and this part. So we know that for a pi graph, in our case here, this becomes 5x. So if we're dividing by pi, this becomes 0 to pi over 5. So pi over 5 becomes this one here. And this one becomes negative pi over 5. Because that would be a regular, oops, I put a 2 there. Okay, and then what's halfway between pi over 5 and 0? Well, that's negative pi over 10, right? And this one is negative pi over 10. Okay, and then we just draw a bit of a straighter tan graph because of the 3. Okay, we could always check these on a calculator as well. Okay, so our next center point would be here. Okay, so going to the right of it would be going up here. And this would be our next center point, and going to the left of it here would be going down straighter. And that's how you would draw that graph. And now, again, with the tan graph, you can chop off the last after the pi, regular pi. So you're only, with the tan graph, you only need 2 notches on both sides because it repeats itself in half as long as a sine or cosine graph would. Okay? So take a look at page 55. It gives you the reminder formulas, or it gives you a good summary there. It says what happens with the A value and the B value there. So on page 55, keep that in mind. And we will be going on in the next section to be looking at drawing graphs with two other coefficients added in now.